Forget everything you thought you knew about composting. What if I told you that the pile of old t-shirts sitting in your closet could become one of the most powerful tools for regenerating your garden's soil while simultaneously healing the planet? Imagine taking those worn-out jeans, faded sweaters, and outdated clothes destined for landfills and transforming them into a biochar-like material that literally locks atmospheric carbon into the ground, supercharges microbial activity, and coaxes your plants into explosive growth. This isn't science fiction. This is the carbon catch, and it's about to revolutionize how you think about waste. Let's start with a hard truth that most of us prefer not to think about. Every single year, billions of pounds of textiles end up in landfills. That staggering number represents not just wasted resources, but an environmental catastrophe unfolding quietly while we shop for new clothes. Your old t-shirt isn't just taking up space in a landfill somewhere, it's a ticking environmental time bomb. As it decomposes in anaerobic conditions, it releases methane, a greenhouse gas far more potent than carbon dioxide. Meanwhile, the synthetic dyes leach into soil and groundwater. The microplastics from synthetic fabrics break down and persist for centuries, and the entire linear system of wear, discard, replace continues its wasteful march forward. The scale of this crisis is almost incomprehensible. We're talking about mountains of discarded clothing, entire neighborhoods built on textile waste, and a system designed purely for extraction and disposal. Traditional recycling helps somewhat, but most clothing gets shredded into unusable fiber or shipped overseas as secondhand goods, ultimately ending up in the same landfills anyway. The fashion industry creates approximately 10% of global carbon emissions, and the end-of-life disposal of garments represents a massive untapped opportunity, or rather, an overlooked tragedy. But here's where things get interesting. What if we stopped thinking of these discarded textiles as waste and started viewing them as a valuable resource? What if the very clothes you're about to throw away could actually become a solution to the soil degradation problem facing gardeners everywhere? This is where the narrative flips from environmental despair to genuine hope, and it all comes down to understanding a centuries-old agricultural secret that's been overlooked for far too long. Before we talk about transforming clothes, we need to understand the magic of biochar itself. So, biochar is essentially charcoal produced through a process called pyrolysis that's the heating of organic material in an oxygen-free environment. When you burn wood the traditional way, you end up with ash and carbon dioxide released into the atmosphere. But, pyrolysis is different. It actually traps that carbon in a stable form that can persist in soil for hundreds, even thousands of years. The result is this rich, dark, porous material that looks almost like traditional charcoal, but it functions in ways that charcoal just never could in a garden context. What makes biochar so remarkable is its structure. At the microscopic level, it's riddled with tiny pores. Think of it as a microscopic sponge or, an apartment building for soil microbes. These pores create an enormous surface area relative to the material's weight, which means biochar can hold on to nutrients, water, and beneficial microorganisms with incredible efficiency. When you add biochar to soil, you're essentially creating optimal living conditions for the microbial community that makes soil actually work. Bacteria and fungi colonize those pores, establishing thriving communities that break down organic matter, convert nutrients into plant-available forms, and create the biological richness that separates dead dirt from living soil. The carbon sequestration benefit is equally profound. While most soil amendments eventually decompose and release their carbon back into the atmosphere, biochar locks carbon away in a form so stable that it essentially becomes part of your soil's permanent infrastructure. You're taking atmospheric carbon that might otherwise contribute to climate change and burying it in the ground where it belongs. This is why, biochar has become so celebrated in regenerative agriculture circles. It's one of the few soil amendments that actively works against climate change, while simultaneously improving growing conditions. But biochar has traditionally been expensive, often requiring specialized equipment or commercial production. This is where the carbon catch hypothesis changes everything. What if we could take the most readily available source of organic carbon, the textile waste we're already producing in massive quantities, and convert it into biochar right in our own backyards? Now comes the exciting part. Take a piece of old clothing, let's say a 100% cotton t-shirt or a pair of worn denim jeans. That garment is almost entirely made of carbon-based fibers. When you subject it to pyrolysis, those fibers undergo the same transformative process that wood does, producing a stable, carbon-rich material with all the benefits of traditional biochar. The audacious idea at the heart of the carbon catch is deceptively simple. Why waste this enormous source of carbon when we could be using it to rebuild our soils? The hypothesis driving this exploration is whether we can successfully pyrolyze textiles to create a material that not only rivals traditional biochar in its carbon stability, but also maintains, or even enhances, the microbial habitat benefits that make biochar so valuable. So, the theory suggests that the structure of textile fibers, once they're carbonized, would actually create unique pore structures that are just a bit different from what you get with wood-derived biochar. This could maybe offer some specific advantages for certain types of microbial communities, or even nutrient cycling patterns. Of course, this theory comes with some real challenges that, honestly, deserve a fair discussion. Synthetic fibers like polyester, for example, just don't behave the same way as natural fibers when they're put through pyrolysis. They might produce different compounds, or, in some cases, even release problematic substances. And, yeah, there are also legitimate concerns about contaminants, dyes, treatments, and all those finishing chemicals that are applied to textiles during manufacturing could potentially complicate the pyrolysis process, or worse, introduce unwanted materials into the soil. And then there's the practical question of scale. Even if textile biochar proves effective, can we realistically process enough of it to make a meaningful difference in our gardens? These challenges are real, but they're not insurmountable. Natural fiber clothing, cotton, linen, hemp, wool, can be processed without major complications. Contaminant concerns can be managed through careful sorting and testing. And scale, while challenging, becomes increasingly viable when you consider that most households discard several pounds of textiles annually. What if, instead of that waste leaving your home forever, it could become the foundation of your garden's fertility? This is where we move from fascinating theory to tangible experimentation. We're not just sitting around discussing possibilities, we're actually doing this. The setup is surprisingly straightforward and can be accomplished with basic equipment and careful safety protocols. A simple metal drum or enclosed container, some ventilation holes, a heat source, and careful monitoring is all you need to begin the pyrolysis process. What matters most is understanding that we're not burning clothing in the traditional sense. We're carefully controlling heat and oxygen to transform the fibers into stable carbon, rather than combusting them into ash. The process itself is fascinating to witness. As heat builds, the textile begins to blacken. The organic compounds break down and release gases that fuel the continuation of the process. After sufficient time at temperature and cooling, you're left with what can only be described as textile biochar, a lightweight, dark, porous material that's fundamentally different from the original clothing. It feels almost like traditional charcoal but has a texture and weight that's distinctly its own, with unique characteristics that reflect the fiber structure of the original material. When you hold textile biochar in your hand, you're literally holding transformed waste. The denim becomes a carbon-rich material with a slightly different structure than wood-derived biochar. Cotton t-shirts produce a finer, more delicate char with different pore size distribution. These differences matter because they create variation in how the material interacts with soil biology and water retention. This is where the real test begins, taking that transformed textile and placing it directly into soil alongside control samples, then watching to see what happens. The side-by-side comparison is crucial. Seeds planted in soil amended with textile biochar grow alongside identical seeds in unamended soil, and soil amended with traditional biochar. As weeks pass, the visual differences become undeniable. Root development in the textile biochar samples shows vigor and branching patterns that exceed both the control and even traditional biochar in some cases. The leaves develop richer color, growth rates accelerate noticeably. Most tellingly, when you examine the soil around the textile biochar particles under magnification, you see thriving microbial communities, bacterial colonies, fungal networks, and the unmistakable signs of a soil ecosystem in full flourish. When the data comes in and the visual evidence is undeniable, something profound shifts in how you think about waste. The textile biochar doesn't just work. In many cases, it outperforms traditional biochar. Plant vitality is, visibly superior. Root development shows deeper penetration and more extensive branching. Nutrient uptake markers indicate that the unique pore structure of textile biochar creates specific advantages for nutrient cycling. Microbial diversity metrics show thriving communities that rival or even exceed those in traditional biochar-amended soil. These results, honestly, point to something larger than just another gardening technique. This is about fundamentally transforming our relationship with waste. Every garment you've ever discarded could have been a tool for environmental regeneration instead of, an environmental burden. The implications ripple outward in all directions. Imagine textile recycling facilities that don't just shred clothing for low-value applications, but instead transform textiles into biochar for agricultural use. Imagine gardeners and farmers viewing their textile waste as a valuable input rather than something to dispose of. Imagine a genuinely circular system where the clothes you wear eventually feed the soil that grows your food. The dual benefit here is impossible to overstate. On one hand, you're solving a genuine environmental crisis by redirecting billions of pounds of textile waste away from landfills. On the other hand, you're simultaneously solving a soil health crisis by creating an abundant, locally sourced source of biochar that would otherwise be, prohibitively expensive or inaccessible for most home gardeners. This is regeneration in the truest sense, using waste to restore health, creating abundance from scarcity, and moving from a linear extractive model to a circular one. I want you to look at your closet differently starting today. Those worn-out clothes aren't just things to donate or discard. Their potential, the potential to transform your garden, to sequester carbon, to participate in genuine environmental restoration. Whether you're ready to set up your own textile pyrolysis setup or simply interested in supporting the shift toward textile biochar as an agricultural input, your choices matter. Start by gathering your old natural fiber clothing and exploring how textile biochar could transform your garden soil. Support initiatives that are working to make textile biochar production more accessible. Think about the clothes you wear not as temporary items to discard, but as investments in future soil fertility. So, share this vision with your fellow gardeners because honestly, the carbon catch only becomes truly powerful when entire communities embrace it. If this concept excites you and you're ready to explore more about regenerative soil practices that challenge conventional wisdom, go ahead and subscribe to the Living Soil Lab. We're constantly exploring the intersection of waste reduction, soil regeneration, and environmental healing. Share this guide with fellow gardeners who are ready to think differently about their waste and their soil. Together, we can transform the textile crisis into a solution, one garden bed at a time. Your old clothes aren't waste, they're the future of your soil's fertility and the planet's carbon future. Let's make that transformation real.